We thought 2030 was the humanity would finally see humanoid robots outside the lab, but Unitree's update just changed the math. The validation year isn't a decade away, it's 2026. And today, we're breaking down exactly why. We're breaking down the IPO wave, the Unitree data flywheel, and what this confirmed future looks like. Let's start the main video.
For years, the humanoid robotics industry lived on a diet of viral clips. We watched faceless machines perform backflips and parkour, but those heavily edited showcases are now meeting a wall of rigid financial data. Mechanically complex demonstrations, like the Boston Dynamics Atlas, proved that high mobility movement on uneven terrain was a solvable engineering feat. In 2026, the industry's focus is shifting. Success is no longer defined by a physical stunt, but by the contents of a quarterly earnings report. We are seeing the first cluster of major public offerings. Unitree recently priced at a $9 billion valuation on the STAR market, while Agility Robotics is moving toward a $2.5 billion SPAC merger. Developing these machines requires intense, multi-year spending on engineers and data. These companies are moving toward public markets to secure capital and establish benchmark valuations before private funding cycles tighten. This pivot marks a transition from venture-backed speculation to public market accountability. For the first time, robotics companies have to show their receipts. Private funding is often driven by narrative and future potential. Public markets, however, rely on disclosure discipline and the legal requirement to be transparent with investors. SEC filings reveal metrics that promotional videos ignore. This diagram shows the typical gap between a company's claimed capabilities and its verified commercial revenue. Financial disclosures make it difficult to hide execution failures. If a machine has a low mean time between failures or high maintenance costs, the quarterly numbers will expose the lack of efficiency. These public stock prices establish a benchmark for the entire sector. Legacy private valuations now have to be justified against the unit economics reported by traded companies. An IPO functions as an operational stress test. It removes the marketing layers to reveal if a machine can actually scale within a profitable business model. Unitree's August 7th Investor Roadshow provided one of the first detailed looks into the operational hurdles facing a high-volume manufacturer. During the roadshow, Unitree management asserted that they have reached a breakthrough in volume production for basic structural components and motion control. Even with those mechanical claims, the disclosures identified two primary bottlenecks: the brains, or embodied AI models, and the hands, specifically their fine dexterity and long-term durability. Unitree's current investment roadmap reflects this. They are shifting resources away from purely mechanical engineering and toward massive R&D for intelligent behavior models. Part of the strategy includes a partnership with DeepSeek. The goal is to develop artificial intelligence that can translate general reasoning into high-performance physical actions on the factory floor. The physical robot has become a vessel, waiting for cognitive AI and fine motor control to reach industrial robustness. Training large behavior models, or LBMs, requires vast amounts of physical data. To learn, the AI needs to see how these humanoids interact with real-world objects in unpredictable, dynamic environments. This flowchart illustrates the data flywheel strategy. Companies use teleoperation, where human pilots remotely drive robots to generate raw behavioral data. This creates a closed loop. Every human correction updates the AI's policy, allowing the system to refine movements without manual reprogramming. Early factory pilots currently function as data harvesting machines. Rather than immediately replacing human workers, these robots are on the floor to record the friction of real-world tasks. Tesla's Optimus program utilizes internal factory deployment specifically to gather proprietary training data for its autonomous models. To improve, robots must leave the laboratory. Encountering the unpredictable variables of a working warehouse is the only way to effectively train a large behavior model. In this context, 2026 is a validation year. The industry is focused on proving data collection strategies rather than achieving immediate, widespread industrial scale. The demand signal in public filings supports this. Over 70% of current humanoid revenue comes from research institutes, confirming most machines are in pilot phases. Commercial readiness is measured through operational data: uptime, throughput, repeatable cycle counts, and paid multi-month contracts. The humanoid industry is moving into a new phase. By embracing public market accountability, robotics companies are finally being forced to prove their economic worth on the factory floor.
The IPO wave isn't just a funding event, it's a stress test for hardware reality. Public markets demand scaled execution, not just perfect demos.
While everyone watches the stock price, the real moat is the velocity of the data flywheel. It's the cycle of sensor data feeding back into simulation loops.
Unitree's G1 isn't just a product, it's a validation of their new thesis, moving from singular prototypes to infrastructure-grade hardware.
2026 will be the true inflection year for humanoid deployment. Until then, every headline needs to be filtered through one lens.
Signal over hype. If you found this breakdown valuable, like and subscribe for weekly depth on the robotics frontier. I'll see you in the next one.